Hello everyone, I'm Trinh, Senior Application Engineer for Valin Corporation. Today I will illustrate how to set up the Oriental Motor AZD-KREP with PLC using Ethernet IP. So here's the system configuration. So here's the driver itself, and basically this you need to supply power to the control supply power to this connector here, as well as the main power to the power connector here. So there are 4 pin, and you need to connect it, and then the and also the power supply, 24-volt power supply. Okay, the driver itself, you can use the software utility called MEXE02 initially to set it up, and that's all you need to do. Sometimes you don't even need it. By standard, there are some defaults already will work for that, but if you want to, you can get into the MEXE02 utility and change parameters and stuff like that. Then what you see here is another cable connected to PLC if you want to. This I/O cable, it basically allows you to have a 2 additional hardware input if you want to, one for stop and one for free, meaning you can turn it on and you can rotate the motor freely, or if you want to stop it, then using the physical input, you can do that as well. Not to say that you cannot do all that via Ethernet IP, but this is just an extra additional 2 inputs into the drive that you can control from your output of the PLC. And then from the PLC standpoint, this is a scanner. So the scanner, the Ethernet IP scanner, you basically connect the RJ45 to the RJ45 port here. There are actually 2 ports here. So once you connect the Ethernet cable to this, and then you can connect to that on the driver itself, there's like a internal switch, if you will. So you can use the other port connected to another motor or another Ethernet IP compatible product, which is great. So you don't really need a switch. Okay. Now, so that's the system diagram. This shows a little bit in detail how it looks. There's a USB connector here. This is where you connect your Oriental Motor utility MEX02 to it. Here's the input signal that I was talking about before, the free and stop. There's some LEDs here for power, alarm, the master. So if you have any communications, these LED will lit up. So it indicates basically you have communications. If it's red, it's something wrong with it. If it's all green, then it's all good. There's an IP address setting here on the rotary switch, and that basically allows you to set up the last octet of the IP address. So in this example I'm going to show you, I set it up to be 2. So the rotary switch need to be 2 for 192.168.1.2. And here's the connector for the 24-volt power for the main power, as well as for the control power. And on the side here, these are basically showing the power connector here. This is the motor encoder, electromagnetic brake connector, if you have them, are in here, which is this port right here. And then here's the Ethernet IP connector that I mentioned, CN3 and CN4. So that's a little bit on the hardware. Here's the pin assignment for the control power supply as well as for the main power supply. These are pin assignment for the stock control input 0, which is stock, and control input 1 for free, meaning when you turn it on, activate it, and the motor can move freely. As far as the Ethernet IP, so on the Ethernet IP itself, you have from the scanner to the drive, there are 40 bytes. And then from the driver, or Oriental Motor AZD-KREP, there are 56 bytes. and then we'll go over the assembly and so forth. You can call us or email us, and we'll get you the EDS file, which is the Ethernet IP, a file that you needed for your PLC. In this example, I just happen to use an Omron PLC as a scanner, but it can be any PLC scanner from Mitsubishi, from Wago, from Siemens, or Allen Bradley. Here's a little rotary switch I was mentioned. So I set it up for 2 in my example. Here's a little bit, basically the map of the input into the drive, as well as the output to the drive. So this side is basically the output register from the scanner to the Oriental motor. And here's the inputs registers from the Oriental motor to the scanner. Okay, so these are number of bytes. As you can see, the outputs you have from 0 to 39, which is 40 bytes. And for the inputs, you have from 0 to 55, which is 56 bytes. This shows the input data. So the assembly for the input is 100. Also, you notice this is the order is Little Indian format, and this is important when you set up on your PLC how to read and how to write. So 100 is for the input data format, and these are, so besides the fixed I'm not going through detail on all this, but when they mentioned remote I/O out, they meant this right in here, the first 2 bytes. But also there's a fixed I/O byte, which is register 4 or 5. This is what we're going to use mostly to jog the servo forward or backward, execute the position. 6 and 7 shows the present alarm. 8 to 11, this is the feedback position where the motor is. You can also get the feedback speed, command position. You can also monitor torque, the operating current, and so forth. So that's from the drive into the scanner. For the output, the assembly is 101, and it has 40 bytes. And on this one, I mentioned remote I/O before. Fixed I/O, this is where you will tell the drive, again, to jog forward, jog backward, reset alarm, or execute the position that you put in here. The registers 6 and 7 basically indicate whether you want to do absolute move, incremental move, and so forth. There is a, so if you want to set up the motor to go to a certain distance with the speed, accel, decel, this is the register that you would fill it in. For example, register 12 to 15 for direct data operating speed. If you want to put in the acceleration, that's 16 to 19. For deceleration, that's 20 to 23. And then for the operating current, that's 24 and 25. And the actual value of the data of the distance that you will tell the motor to go, number of pulses, that's 26 and 27. And these are, if you want to write certain or change parameters, this is what the write parameter ID and the read parameter ID and so forth. For the demo, I'm just going to concentrate and show you how to set up the speed, the accel, the incremental move, and how many pulses we're going to send it up. And we're going to use fixed I/O to jog forward, jog backward, set, wherever the motor is at, we set it 0, and then we execute the move based on the number of pulses that I put in it. Okay? So fixed I/O, right? So the bit we're going to use in here, basically bit number 8, to tell the motor to move to number of pulses that we provided. And let's see. Oh, this is the input, so it didn't show the jog forward and jog backward, but that's basically 0 and 1. So these are remote I/O that you can program it right now. These are the name for it. But I'm going to use the bit 0 to use wherever the motor is. I'm going to use that bit. When I turn that bit on, I can make that is 0 for this demo. This is the different operating mode that you set up. So right now we're going to use incremental positioning. So I'm going to have to put 2 into that register, which I'm going to show you later. So here's an example that we're going to do. We're going to set up the system so that it has 5,000 steps, meaning every time I execute a move, it will incrementally move 5,000 steps wherever it is. By the way, this is basically 1,000 steps per rev. So 5,000 steps means 5 revolution. The operating speed is 1,000 hertz. Starting frequency is 1. So that's the 1,000 kHz. The stopping deceleration is 1,000 kHz. So this is accel and decel basically. I'm going to put 100% for operating current. So that's what we're going to do. So how do we do that? We basically need to put in these values into the register. So to do this incrementally, we have to put a value 2 into register 6 and 7. We have to put in 5,000 into 8 to 11. That's the register. And the speed is 1,000 as well. We need to put that in register 12 and 15. 1 million, which is 1,000 kHz for the accel. That's register 16 to 19. Million hertz per second, that means 10,000 hertz per second. We need to put that 1 million, the value 1 million into register 20 to 23. And I'm going to use 100%. That means the value 1,000 need to go into register 24 and 25. And that's it. So that's how we're going to do this. And this is kind of show the step, what happened in the timing diagram. But we're going to do that in the demo. So let's go to the demo. So what you see in front of you right now, this is the Oriental Motor AZD-KREP Ethernet IP. Everything as a one package right here. Okay. So I have the Ethernet cable here that connect to my PLC. These are encoder cable, a power cable, as well as the power to the drive that I'm connected to 24-volt power supply right here. Right now, I'm just jumping the main and the control power to the negative 24-volt DC here, and 0 VDC and plus 24-volt VDC. So that's our setup, okay? And on this side, I'm using what you're looking at, basically the Omron Sysmac Studio, which is the development software to set up the Ethernet IP configuration and also simulate what we're going to do for the example I just mentioned above. So just real quickly, so here's the target device, which is 192.168.1.2, which is the IP address for the Servomotor, Oriental Motor, Servomotor. So that's for that. And I create 2 global variable. And that is, let me see. Need to bring this down so you can show. Okay. So you notice in here, I have a input and I name it KREP_out. That means these are outputs from the Oriental Motor into the input of the PLC, the Omron NX PLC. Okay. Now, so you need to set up that. That's for the input, and then so that's the 56 bytes. For the output, it's actually 40. And the label, the global variable for that is KREP_in. And that's 40 bytes. And if you look further under the global variable, you notice that I create these global variable with an array 0 to 55. That means 56 bytes. And that's the input. You need to make this the network. Publish is input. And then for the KREP_in, that has for the byte, which is an array from 0 to 39 of byte type. And the network publish is the output. Okay, so these are important if you are using Omron PLC. This is what you set up. And then you download it, set up. So now let's do something with this, right? So right now, I can jog the motor by turning on bit 0 of that byte number 4, which is the very first bit here. I'm going to do that. As soon as I click enter, the motor will be spinning. Here we go. See? So now it's jogging one direction, right? I'm going to go ahead and stop it. To stop it, easy. You just sit 0, boom, it stopped. If you want to go the opposite direction, which is the next bit, that's bit number 1, which is this bit here. As soon as I do that, you will see the motors spin the other way. Here we go. Okay? So that's how you jog the motor forward and backward. I'm going to stop it now. Okay. So wherever it is, right? And you know wherever that is, because down here, actually, let me see here. We'll go back to the PowerPoint. Yeah. So here, the current position basically is 8 and 9. That's what I was looking for. Okay. So register 8 and 9. So go back to what we have. So 8 and 9 has these value in it. Okay. I want to show you this so that when I execute, wherever that is right now, I want that to be 0. So watch 8 and 9 has EFEC value, right? So we're gonna make that to be 0. To do that, I'm basically turn on the very first bit here. And the reason I do this to show you this is a one way to home it. You can move to wherever that is, you can jog to it, and then you turn on this bit. I'm gonna turn it back 0. And if I look at 8 and 9 now, it should be 0. Interesting. I think I know why. I'm gonna use this and make sure it's out of the info mode. I think that's a problem. Usually you don't have this problem because I just playing around with the MBX02 earlier. So this is the utility right here. Okay. So I'm going to connect to it. Okay. Actually, let me come back to that. So for now, we're going to program it so that it will move 5,000 steps. So 5,000 steps means 1388 in hexadecimal. And how do I know that? If I go to my calculator here, right? 5,000 step means 1388 in hexadecimal. So I need to put in 1388. So which is at 1388 right now. So at this point, I'm going to turn this bit off first. To tell it to go to 5,000 step, I'm going to actually turn on that bit right now. And as soon as I turn that bit on, it will move 5,000 step, which means 5 revolution. Okay, so watch this. 1, 2, 3, 4, 5, and then it stopped. If I want to execute it one more time, then I do the same thing. Put the 0 and then put 1, and it will move incrementally another 5 revolution. 1, 2, 3, 4, 5. So basically, that's how you set up the Ethernet IP configuration and program it using the PLC, any PLC, from Allen Bradley, Siemens, Mitsubishi, Wago, to the Oriental Motor AZD-KREP Ethernet IP modem. Thanks for watching, and let us know if you have any questions by calling the number below. Thank you.